Okay, so on the test, you will be told specifically which method to use, so you have to be able to utilize all of them. But that wasn't the case on the practice test. You could use whichever method you wanted to. What I'm gonna do for the review is I'm gonna use the method which would probably be ideal, the one where like the way that it's set up, it would make the most sense to use, which is typically what you're given on the test. On the test, they're not going to ask you to use a quadratic formula on something that's quicker to solve by using square root property or vice versa, anything like that. So because I have the constant here on the other side, what do you think would make the most sense to solve this one with? I would complete the square. Okay. We also have a perfect square up in front, so that's all I have to do is complete the square. The formula I gave you for completing the square, even though it seems like it was forever ago, was b squared over 4a, which is 100 over 4, which is 25. So if that number 25 completes the square, I'm going to add that to both sides. I'm going to say x squared minus 10x plus 25. I get a 9 plus 25. By completing the square, that means I can now factor on the other side negative 9 plus 25 is 60. The way I showed you to factor was take the square root of the first and last. What's the square root of x squared? What's the square root of 25? Keep the sign in the middle. By doing this, now we only have a single x. So that means I can use square root property to tell me that x minus 5 is equal to plus or minus 4. When the plus and minus shows up, are there any square roots left? Do you see any square roots still in the equation? No. Has the variable been isolated? No, so we just split. So x minus 5 is equal to 4. X minus 5 is equal to negative 4 plus 5 plus 5. So x equals 9 plus 5 plus 5. X equals. Any questions there? Okay. This one here is not necessarily set up for anything in particular because we don't have the variables all on one side. We don't have all the terms on one side. So you could kind of pick. I mean, there's no, probably wouldn't get anything like this on the test, but I don't know, since I have carte blanche to do whatever I want here, I'm just gonna move everything to one side. If ever you have a choice, use quadratic formula. Going forward, that's what we're gonna use is quadratic formula more often. So I'm gonna start off by doing plus 2x and minus 8 plus 2x and minus 8. And now move everything over on one side. So that a is 1, b is 2, and c is negative 8. Quadratic formula says that the variable you're looking for. If b is 2, what's negative b? Negative 2 plus or minus the square root of 2 squared minus 4, a is 1, c is negative 8 over hope you're writing all this down. What's 2 squared? How many negatives do we see after the square? 2, so that's going to turn the sign into a plus. So now you don't have to type in any negatives to your calculator. Just put 4 times 1 times 8 is 32. When I finish adding, I get a 36. What's the name of that number? That number has a name. It's the discriminant. Yes, we have it. If somebody were to ask you what is the discriminant in this equation, it's 36. Now, yes, so it happens to be not only positive but a perfect square. What that tells us is that our solution is going to end up being rational. We're going to be able to get rid of the square root. We're going to have two real and rational solutions. Square root of 36 is 6. The variable has been isolated, but we are not in simplest form, and we still have the plus or minus, so we should split it. Negative 2 plus 6 over 2. Negative 2 minus 6 over 2. So x is equal to 4 over 2. X is 2. X is negative 8 over 2. X is negative 4. So x is equal to 2 or negative 4. Same ones are going to be on the retake. Got until tomorrow. Also, one of the ones missed the most. What do you think would be ideal for solving this one? Meaning, if you were to see it on the test tomorrow, this would be what you were most likely to see. Like you would see it under this method. Like they would be telling you more than likely to solve this. How many x's do you see? Just one. It's the one that's being squared. This is the first method that we used after factoring, when there was only a single x. Use square root property, which was like just treat it like if it was linear. Isolate the variable normally, since we don't have a regular x to contend with. We can just go plus 1 plus 1. So 7x squared is equal to 63. Divide by 7. So x squared is equal to 9. Once you take the square root, what's the square root of 9? Plus or minus 3. When you take a square root in an equation, you need the plus or minus. So x can be positive 3 or negative 3. Adrian, any questions? Okay. What do you think would be the ideal one here? Again, you're going to be told what to do, but more than likely, if something is quicker to be solved a certain way, like that's what you're going to be asked to do. You're going to be asked to do it specifically this way if something like this shows up. Go ahead. So you might be the only one. Huh? Yeah, use square root property here. And how do you know that? So how do you know to use square root property? Because there's only a single x. And you're like, oh, but Mr. Romero, that's not quadratic because there's a 1 on top of it. Yeah, but it's inside of a parentheses with a square on the outside. Which means in order to isolate it, you have to use square root property. So now I just get 2x plus 1 is equal to What's the square root of 144? Positive and negative 12. There are no more square roots left. Has the variable been isolated? So you should split it. 2x plus 1 is equal to 12. 2x plus 1 is equal to negative 12. Minus 1 minus 1. So 2x is equal to 11 divided by 2. I'm pretty sure I left these as fractions. I mean, even if it was a decimal, you would just divide. It gives you 5.5. But I think I remember I left it as a fraction for the answer choices. So 2x is equal to negative 13 divided by 2. So those would have been the two solutions you would have. That was 11 over 2 and negative 13. Irma, any questions for you? Ask them now. You have a test tomorrow. You have 2 tests. We have the test tomorrow, 1 more test, and then after that is the final. Hey, for the 3rd time in a row, what do you if you were to see this on the test tomorrow, more than likely, what method would you be being asked to use in order to solve? Yes, Louis. Yeah, more than likely square root property. Can it be solved the other method? Sure, but then you'd have to like expand that binomial. You'd have to like multiply x plus 3 times x plus 3. It would take a long time. It's just not necessary. The beautiful thing about this is that there's only a single x. So now, just as important as understanding what method to use is actually how to use the method. So on the last one that we did, our first step was to get rid of the square. What would my first step be here? No, definitely don't want to distribute. The whole point of this is to avoid distributing. Huh? Yeah, it's to get rid of the 2 on top. Not by distribute. No, number one, even if you wanted to, you could not distribute that. Because PEMDAS says that exponent comes before multiplication. And if I can't do the exponent, I can't do the multiplication. But all I'm trying to do is isolate. So I can get rid of the multiplication by dividing. Remember, when you're canceling, you go reverse PEMDAS. So I can get rid of that 2 first. I'm assuming a lot of you spent most of the week studying and going back and looking at the old videos and notes and stuff. But if you do go back and watch the video when square root property was taught, we did a bunch like this. Right, Salim? So x plus 3 is plus or minus 4. Don't forget the plus or minus. X plus 3 is 4. X plus 3 is negative 4. Minus 3 minus 3. X is 1. Minus 3 minus 3. X is negative 7. So X is 1. Tiffany, you got that? Down. Questions? If anybody, just to be clear, if anybody was not here, or if for some reason your score didn't register, I don't think it happened to as many people this time, but you can only do the retake once. But as long as you were here and you got a score, you can do it twice, and I'll take the higher of the 2. Hey, how many x's are there? So what do you think would be a good method to use here? Okay. What would be, Ali, what would be the first step I would do here to get the x by itself? Very good. Yeah, I want to get rid of the 2 minus 2. And then parentheses and the square. Now I can get rid of the square by a square root. This works out beautifully. Because 4 is a perfect square. There's no more square root, but x is not by itself, so we'll split it. Over 3. I gave back the work to you guys for a reason. Is anybody actually like looking through the work and see if you can find these exact same problems and maybe you can catch your mistakes and see what you did wrong if you got it wrong? That's why I gave the work back. Fifth time in a row now? How many x's do you see? Does that mean that square root property is the only way you can solve this? No. Somebody even actually sent me a message over the break, and of course I responded because that's how awesome I am. Because they were trying to do work on the homework, and they saw something like this, and it fell under quadratic formula, and they're like, "But Mr. Romero, how can I do this with quadratic formula?" Oh look, it's already equal to 0. So A would be 16, B would be 0, and C would be negative 25, and you would plug that into the quadratic formula. And that's an awful lot of work when it's not really necessary. Because of the fact there's only one single x, I would just use square root property. Add 25 to both sides. Ellie, what would I do next? Oh, oops. Well, you actually could. You could square root and you would get away with it because 16 is a perfect square. I don't advise it. If you're going backwards PEMDAS, are we getting rid of an exponent first or are we getting rid of multiplication first? Backwards PEMDAS? Yeah, I would divide by 16 first. Because what happens is if that number's not a perfect square and you try to square root, good luck. And now at the end, I would square root. Square root property says I need a plus or minus. You're like, well, Mr. Romero, this is why it was so hard, because how do you take a square root of a fraction? You just take the square root of each number. Square root of 25 is? Square root of 16 is? Ta-da. How many problems were there on the 23? Yeah, there was 23 problems on the practice test, and I'm doing 12 of them for you. So I'm doing more than half the test, as long as you're willing to pay attention and write everything down. I would hope that that's a pretty good deal. So I guess it looks like we're starting to notice a trend, right? And these are the ones that we missed the most. So the question is, did we miss these the most because they're the hardest, or because they were the ones that we had learned, like they were the most distant, like this is what we learned first? wasn't the most recent. How many x's do you see? So I would just use square root property, minus 6 minus 6. 5x squared is equal to 80. Ellie, what do I do next? Good. You see, like on this one here, if you try to take the square root, mathematically there's a way you could do it, but then you got to take the square root of 5. And then it just works out perfectly because 80 divided by 5 is 16. So Louis, what do we end up with? Plus or minus 1. Ooh. See, this one's a lot harder. Here I see two different x's, but they're both squares. So if they're both squares, that means that they're like. So if I could put them on the same side, I'd be able to combine them. So even though this looks different, I'm still going to do this with square root property. I'll move all the x's to the left. I'll move all the constants to the right. What's x squared plus 2x squared? 3x squared is equal to 75. Hope, what do you want to do next? Adrian? Good. Divide by 3. And again, it works out beautifully. 75 divided by 3 is 25, which is a perfect square. So Irma, what's the square root of 25? Rika, you got that? See, for the first time in a long time now, we have an x squared and an x. So, based on what's going to be available for you on the test tomorrow, this is either a quadratic formula problem or a completing the square. Tomorrow's test is on three methods: square root property, completing the square, quadratic formula. Okay. When you have both different types of x's, it's either completing the square or quadratic formula. Tiffany, since you love both of them like children, and even though it's hard to pick between kids, which one is your favorite? You want to ask Isaac to see if he has a favorite? You know that I kicked somebody out of class last period for the same thing, right? Tiffany? It's okay, it's really boring. Emma, you want to help out? Like the point I'm trying to make is for this one here, they don't have all the terms on one side. It's not equal to 0. They don't have all the variables on one side. So really you can pick. You can pick whichever method you want to use. Yeah, that's probably what I would pick. If ever I'm given a choice, that's the one I'm going to pick. Good choice. 6x squared minus 5x. For quadratic formula, you got to move everything to one side. Lana, what's A? What's A? And what's B? Yeah? Negative 5. And what's C? Sarah, are you writing this down? is equal to, if b is negative 5, what is negative b? Yeah, it's going to be positive 5 plus or minus of squared. Minus 4, 8, 6, negative 6, 1, 2 times 6. So 5 plus or minus of. How many negatives come after the square? 2, so that's going to be a plus. That's one less mistake for you to make. Typing in negatives into a calculator. 4 times 6 times 6. So 144. 4 times 6 times 6? I'm doing it in my head, but I'm getting 144, right? X is equal to 5 plus or minus 169 over 12, which is 5 plus or minus 13 over 12. So I had a positive discriminant, so not only was I able to take the square root, but because it was perfect, I was also able to get rid of the square root. So since I don't have a square root anymore, once I get to the plus minus, I should split this. And say x is 5 plus 13 over 12, and x is 5 minus 13. Isaac, what's 5 plus 13? That's a hard one. Just think about it and get back to me, Isaac. Negative 8 over 12. You gotta know how to reduce fractions. What did I reduce the first fraction by? What did each number get divided by to get from here to here? 6. Yeah, that's called the greatest common factor. 6 over the greatest common factor. How about here? What was the greatest common factor there? 4. Isaac, you got that? Okay, good. All right. Let's see if I'm making any sense to you, Harold. This one, I could definitely see it being placed under a certain set of instructions. So if you were to be given this quadratic equation tomorrow, more than likely, what would you be instructed to solve it using what method? Yeah, probably quadratic formula, because there's both an x squared and an x, and it's equal to 0. Everything's on one side. Is Vicente? Oh wait, hey Vicente, what would A be if we're gonna use quadratic formula? It would be what? He said 2. Okay, thank you. How about B? That's not what he said. He's covering for it. Huh? He said negative. I thought he said positive. No. Okay, and what's C? Down. X is equal to. Like normally I would give you guys time to do these, but you already had time to do these. That's what the practice test was for. So if B is negative 9, what is negative B? Positive 9 plus or minus the square root of squared minus 4a. How many negatives come after the 81? So I'm going to keep it negative. 4 times 2 times 9 is 72. Over 4. So x is equal to 9 plus or minus the square root of 9 over 4. Sarah, what's the square root of 9? It is 3. So x is equal to 9 plus or minus 3 over 4. Because I was able to get rid of the square root and I still have operations left, I'll split it. So x is 9 plus 3 over 4. X is 9 minus 3 over 4. 9 plus 3 is 12 over 4, which gives me 3. 9 minus 3 is 6 over 4, which gives me 3. Any questions there? Algebra. What would you expect to see as the instructions here? Yeah, pi quadratic. So what would A be? What would B? And what would C be? Oh man, I gotta go back and see if I didn't write the instructions. I'm wondering if some of these were just the ones of how many solutions. So, I guess not, because I think on all the ones with the solutions, I think they were all either they might have all been no solution. I'll go back and check. Time answer this. Let's see. So x is equal to. Remember to only put x if that's the variable. If these would have been y's, I'd be putting y's. So if b is 10, then negative b is negative 10 plus or minus the square root of 10 squared minus 4 a is 3 over negative 10 plus or minus the square root of 100. Since there's two negatives, that's going to be a plus, and 4 times 3 times 8 is 96. Square root of 196 would be 14, right? So once again, we don't have a square root anymore, but we still have a plus or minus, and we're not done simplifying, so we gotta split. X is equal to 4 over 6, which is 2 over 3. This is the actual test here. These were the ones that were how many solutions, but I don't think we've done any of these. Okay, so it looks like you have one of those. let's do a couple of these. I mean, these weren't missed the most, but they were still missed a lot. And I'm guessing if the reason why they weren't missed the most is just because of the fact that it was easier to guess for you guys. I don't necessarily think it means that we're that much better at it. I just think it was just easier to guess. So, if we have time, let's do some of these. That's just these are the ones that said just how many solutions. So what's the shortcut you can use if you want to find out how many solutions? Lewis, you don't have to use the entire quadratic formula. What's it called? The discriminant. Just use the discriminant. Use this, the b squared minus 4ac. So what's b here? What's b? -1 minus 4. A is 3. C is 2. So we get 1. Then there's only one negative, so we keep the negative. 4 times 3 times 2 is 24. So you get -23. How many solutions? Yeah, this would be no solution. So this is now 13 problems I've done for you in a 23 problem test, and there's still time left. I'm going to end up having done this entire test for you. Okay. Same thing, same instructions, how many solutions. The difference here is that it's not equal to 0 for you. So you cannot, even though we're not using the entire quadratic formula, if you're going to use any part of the quadratic formula, you have to make this equal to 0. So minus minus 8x plus 4 minus 8x plus 4. 4x squared minus 8x plus 4 is equal to 0. If you want to find out how many solutions, the same thing. Let's just use b squared minus 4ac. What's b? What's b? -8. Remember, anytime you square a number, you're going to end up with a positive anyways. Minus 4, a is 4, c is 4. So this is 64, and then 4 times 4 times 4 is also 64. How many solutions? If you end up with a 0 discriminant, how many solutions? Yeah, one real solution. You know what? Let's do this. Since I already know I'm going to have a 0 discriminant, let's actually solve this just for fun. And we'll skip some steps. If b is -8, that means that negative b will be 8. But I already know that my discriminant is going to be 0. And the square root of 0 is 0. So that actually knocks out the square root and the plus or minus. So all I'm left with is that negative b over 2a. 8 over 8. So if you given solution have been? It's the same thing, just how many solutions? What's B here? So that's going to be like 9. How many negatives do we see afterwards? So plus, and then 4 times 1 times 1 is 4 is 13. How many real solutions does this have? 2. Yeah, if you have a positive discriminant, this is 2 real solutions. Let's see if I can find one more using completing the square, and then we'll call it a day. Let's do this one here. If this were to show up on the test tomorrow, more than likely, what method would you be asked to use? It's not that it can't be done by quadratic formula, but you're probably going to be asked to complete the square because you see the x's on one side and a constant on the other side. So the good news is that the lead is not only perfect, but it's 1. So I can just go straight into a completing the square, and the formula I gave you was b squared over 4a. So that's going to be 4 over 4, which is 1. So that gets added to both sides. So you get x squared minus 2x plus 1, but then don't forget the 80 also gets added to 1. 1 parentheses with a square, 80 plus 1 is 81. Keep the sign in the middle. What's the square root of x squared? It's x. What's the square root of 1? And now this looks like one of our square root property problems. Square root, x minus 1 is equal to, Ellie? Plus or minus 9. So x minus 1 is equal to 9. X minus 1 is equal to negative 9. Plus 1 plus 1. X is equal to 10. Plus 1 plus 1. X is equal to negative 8. So as long as you were actively paying attention, I have now done 16 problems for you out of 23. Like all you had to literally do was pay attention, and there's a pretty good chance you can improve your score. There's only 7 problems left. Until what time do you have to do this? Until when is if you're gonna do the retake? When is it due by? Tomorrow night. Also, one last piece of advice for the test tomorrow that I just noticed. Go back and review factoring also. Not that it's gonna be. How can I say this? It cannot hurt you to not know factoring. Like it's not like your grade is gonna suffer by not knowing factoring, but it can help you if you remember how to factor, like how to do a factor chart, what the difference of squares is, greatest common factor. So go back and I know it's been a while. Go back and review those.